Two-variable linear inequalities. The graph of a linear inequality in two variables is the set of points that satisfy a linear inequality. The solution to a linear inequality is a region bounded by a line through the plane. One side of the line is shaded to indicate the solution, the other side is not. Here's a linear function, which is a line. Here's a linear inequality, a line with the shaded portion representing the solution. Graphing linear inequalities is an extension of graphing a line. By agreement, a solid boundary line is included in the solution set, while a dashed boundary line is not. So here we have an equal sign, so less than or equal to, so we have a solid line. And here we have less than without the equal to, so this is a dashed line. Deciding what side to shade is a skill that takes some intuition. To start, if the origin, 0, 0, is not on the boundary, test the inequality by setting both x and y equal to 0. If this statement is true, then the origin is in the shaded region. If the statement is false, then the origin is not in the shaded region. Deciding which side of the line to shade is crucial. Test a point like 0, 0 or 1, 0 to decide. To test the origin for inclusion, substitute x equals 0 and y equals 0 into the inequality to decide. So here we have our line. So we're going to plug in 0 and 0 to see if it's true. So if we plug in 0 for x and 0 for y, we get 0 is less than or equal to 6, which is true. So this point is included, so we can shade this whole portion. Here we test this point. 2x minus 3y is greater than 6, so we'll plug in 0 for x, 0 for y. We get 0 is greater than 6, which is false. So the origin is not included, and we shade below the line. The region below is the solution set for the linear inequality ax plus by is greater than 12. True or false? 0, 0 is the solution. Here is 0, 0, and since it's not within the shaded region, it's not a solution, so this is false. 4, 0 is the solution. Here is the point 4, 0. It's on the boundary line. However, in this case, the boundary line is dashed, which means that this point is not included in the solution, so this is false as well. 3, -3 is a solution. That is true. It's right in the shaded region. This is true. This is a solution. A plus b equals -1. So here we're dealing with the coefficients. So to figure that out, let's figure out what the coefficients are. So we have ax is greater than 12. So this will tell us when y is 0. So when y is 0, what is x? What is the x-intercept? So x is greater than 12 over a. We know that the intercept is 4, so we can just solve for a. 12 equals 4a. Divide both sides by 4, we get a equals 3. Let's use the same idea to solve for the y-intercept. So that would be by is greater than 12 because we've set x equal to 0. And in this case, we have y is greater than 12 over b. We know that that point is -3. So we'll solve for b. 12 equals -3b. Divide both sides by -3, and we get b equals 4. 3 plus 4, or -4, sorry, that makes more sense. 3 minus 4 equals -1. This is true. So this was -4 because we had 12 divided by -3. And we got them all correct. To graph a linear inequality, graph the line first and then decide on which region, also called a half plane, to shade. Here we have 5x plus 2y is greater than 10. First, we're going to plot the intercepts, then figure out if the line is dashed or solid. We're going to sketch the line and then test a point in order to shade a region. The first step is to plot the intercepts. So to figure out the intercepts, first we'll set y equal to 0. We have 5x is greater than 10. Divide both sides by 5, we get x is greater than 2. So this is our x-intercept at 2, 0. And for y, we can do the opposite. We'll set x equal to 0. We have 2y is greater than 10. Y is greater than 5. 0, 5 is our y-intercept. Now, do we have a dashed or solid line? Since this is greater than, not greater than or equal to, it's a dashed line. So we can just draw the line. Then we're going to test a point, 0, 0. So I'm going to rewrite this. We have 5x plus 2y is greater than 10. So in order to test the origin, because the origin is not on the line, so this is a good point to use, x is 0, y is 0. Is 0 greater than 10? This is false. Therefore, the origin's not included, and we shade in the portion on the other side of the line. A system of linear inequalities is two or more linear inequalities. The solution to a system of linear inequalities is the intersection of the half-planes formed by linear inequalities. In effect, to solve a system of linear inequalities insists that you repeat the previous lesson with two or more inequalities graphed on a single grid. Solve the system. To solve the system, we put the two graphs together. So here is the graph of x plus 2y is greater than 6. And here is the graph of y is less than or equal to 2x minus 4. When we put both of these graphs into one grid, the solution is the quarter plane, this area here that is shaded in both graphs.